Hello again, this is Miss Nichols, and this is the second lecture in the first unit of the year. The topic is mathematical relationships. Make sure you've got your notebook, set it up for your Cornell notes if you need to, and have your pencil, be comfortable. The volume should be on, and closed captions if that helps you. The essential question for this video is, how can we use mathematical relationships to predict how changing one variable will impact another variable? This is really like important stuff. This is at the heart of all of physics, is wanting to understand the world better and make predictions. And everything we do comes from understanding the mathematical relationships between two different variables. So, as I just said, relationships matter. The goal of physics is to be able to explain what happened and predict the future. To do this, we have to figure out how changing one thing impacts all the other things down the road. The word relationship is just a connection between two variables, and it turns out these relationships end up being the building blocks of equations. You may have seen equations before and felt like, oh, some genius somewhere figured those things out. Equations are really simple to make and really powerful when you understand how you can make your own equations that let you make predictions about things that you care about that nobody else may have ever found out or ever discovered. So we're going to eventually build up to understanding equations, but we got to start by understanding the individual mathematical relationships. In general, the goal of relationship building is to figure out how increasing one variable affects the other variable. And in general, there's three kind of outcomes. It could increase the other variable, it could decrease the other variable, or it could have no effect on the other variable. And those are all outcomes that we see all the time in science. So it actually turns out that the most common relationship in all of physics is known as the no relationship. In no relationship, changing one variable has no impact on the other variable. When you change something, it doesn't affect the vast majority of the other things in the universe, and that's a no relationship. So for example, the length of your hair has no relationship with the grade that you get on your physics test, right? These two people are equally likely to be physics rock stars. And if that person on the right, for example, cut her hair shorter, it wouldn't change how good she or he or they are at physics. And that's really an important thing to realize, that not everything affects everything else. And we call that in physics a no relationship. Some variables have what's called a linear relationship, and you may have heard of that relationship in math class, and if so, you're a little ahead of the game, and if not, this is going to help you in your math class. Linear relationship means that increasing one of the variables will increase the value of the other variable by the same percent. So they both go up together, or they both would go down together. So for example, the number of people in a class has a linear relationship with the number of shoes in the classroom, right? If I have just one person in my classroom, 2 shoes, right? But when I double or quadruple, in this case, the number of people in the classroom, if I have a different classroom with 4 people in it, well, we now have 4 times as many shoes, right? It would be 8 total shoes, but the thing that stays the same is the amount that the variable changed by, the percent it changes by. So we quadrupled the people, we're going to quadruple the shoes. That's a linear relationship. And then some variables have what's known as an inverse relationship, which again, you may or may not be familiar with from math class. In inverse relationships, increasing one variable causes the other variable to decrease by a reciprocal or similar percent. For example, the amount of dinner each dog in a family gets has an inverse relationship with the number of dogs sharing the dinner. So if I had just one dog, it's going to get 1 dinner. But if I double the number of dogs, they don't get more dinner each like you would see in linear. They actually get less dinner, and the amount of dinner they would get is 1/2. So you'll see if you double something in an inverse relationship, the other variable goes down by 1/2. If I tripled the dogs, hopefully you could kind of figure that out, what's going to happen is we're going to have 1/3 as much food. So you'll see that relationship, that reciprocal relationship, in our inverse relationships between variables. All right, that's the end of this slideshow. Please do take a few minutes to revisit the essential question, which is, how can we use mathematical relationships to predict how changing one variable will impact another variable? As I said, this is one of the most critical ideas of the entire year, And I would really encourage you to make use of that Cornell note style and put a summary in your own words, and then maybe even come up with some examples of linear and inverse relationships in your life and experience that you can think of. So please pause the video here, and when you're done with your revisiting the essential question, you can unpause it to get a little farewell from Calvin and Hobbes. Thanks so much for watching.